This is Miss Sebastian, and we're going to look at Unit 5 functions, the functions unit test. What are the next three terms in this sequence? We have -2, 4, 10, and 16. So I'm going to look at the difference between -2 and 4. To go from -2 to 4, I have to add 6. From 4 to 10, I also add 6. From 10 to 16, I also add 6. So I'm going to do the same thing for the next three. So 16 plus 6 is 22. 22 plus 6 is 28. And 28 plus 6 is 34. So those are my next three terms. Jeff planted Delilahs in his garden. Delilahs have bulbs that divide and reproduce underground. In the first year, Jeff's garden produced 3 bulbs. I'm going to write that down so I know that that's important. There were 3. In the second year, there were 9. And in the third year, it produced 27. If this pattern continues, how many bulbs would Jeff expect in the 8th year? So I know that this one is a geometric sequence because it is being multiplied by 3 each time. So I know that 3 is going to multiply by 3 raised to some power. So it's always going to be n minus 1 as the power. Okay, so this first number is the number it starts with. It starts with. And the second number here, the 3, is the number it multiplies by. And all of these geometric sequences will follow this pattern, but we can test it out. 3 times 3, and in the first year we had n minus 1. 1 minus 1 is 0. So 3 times, that's 1, is 3. Now we're going to test it with the second year. 3 times 3 to the 2 minus 1. Well, 2 minus 1 is 1. So 3 to the 3 to the first power is just 3. So that is 9. That's correct. Now we're going to do it again. 3 to the 3 minus 1. 3 minus 1 is squared. That's 9. And 3 times 9 does give us 27. So our answer here for the 8th year, we're going to use our formula here that we just came up with. 3 times 3 to the 8 minus 1, the 8th year. And we're going to say, okay, 3 times 3 to the 7th. So you're going to say 3 times 1, 2, 3, 4, 5, 6, 7. So essentially what you're doing is 3 to the 8th there, because 3 times 3 to the 7th, or 3 to the 7th times 3 will be 6,000 561 bulbs in that 8th year. What are the first 4 terms of this sequence? So I've got n times n minus 1 plus 5. So the first term, all I'm going to do is plug in 1 where I see an n. 1 times 1 minus 1 plus 5. Well, 1 minus 1 is 0. 1 times 0 is 0. Plus 5 just gives me 5. My second term, I'm going to plug in 2. So 2 times 2 minus 1 plus 5. So I've got to do inside the parentheses first. 2 minus 1 is 1 times 2. That'll be 2 plus 5. That gives me 7. So far I've got 5 and 7. Now I've got to do my third one. Plug it in again. 3 times 3 minus 1 plus 5. So 3 minus 1 gives me 2. Then I've got to multiply 3 times 2. That's 6. And I can add 6 plus 5 and get 11. Now I'm going to add the fourth term. So I'm going to say 4 times 4 minus 1 plus 5. 4 minus 1 is 3. 4 times 3 is 12. Plus 5 is 17. So there is my first 4 terms in that sequence. A car traveling at 50 miles an hour slows to a speed of 20 miles per hour in 5 seconds. It maintains that speed for 5 seconds and then slows to a stop after 5 more seconds. Which graph shows that? So you are given a choice on yours to find a graph that portrays what the problem is saying. So if the car starts at 52, okay, it's going here and it's traveling here, okay, and then actually it will go straight down because it didn't say it was traveling right then, so let me erase that. It says it starts at 52 and then it goes down in 5 seconds. So it goes down to 20. So it's going to start here, and it's going to go down to 20 in 5 seconds. So I'm going to draw this line. It's going to go down to 20. Then it maintains its speed. That means it's going to go the same speed for 5 more seconds. And then it slows to a stop after 5 more. So a stop would be at 0. So the graph is going to look something like that. So it's going to start at 52, it's going to go down and then maintain, and then it goes down to slow to a stop after that other 5 seconds. Describe the speed of a remote control car over time. So the speed starts at 4 here, and it's going to go down. The speed decreases until it gets to 3 seconds. Then look what happens. The speed goes up for 1 second, okay, till it gets to 4 seconds, and then it maintains all the way over to 10 seconds. So it maintains or has a constant. This one increases and decreases. Given the function rule f of x equals x squared minus 3x plus 2, what is the output of f of negative 4? So I'm going to rewrite the problem here. X squared minus 3x plus 2. And we want to know f of negative 4. So that means everywhere I see an x in this first problem, I'm going to plug that negative 4. So it's going to say negative 4 squared minus 3 times negative 4 plus 2. So all I did was plug it in where I see the x. So I'm going to write it again and simplify some. I can simplify negative 4 squared. So that means negative 4 times negative 4. That's 16. Negative 3 times negative 4 is positive 12. And then plus 2. So 16 plus 12 is 28. Plus 2 is 30. So the function evaluated at negative 4 is 30. Suppose you earn $12 for each car that you wash. Write a function that describes the relationship between your total earnings, E, and the number of cars you wash. So if you wash one car, you only get $12. If you wash 2 cars, I get 12 and 12, which is 24. If I wash 5 cars, I get 12, 12, 12, 12, and 12. That's $60. So each time that I wash a car, I'm getting $12. So 12 times C. So 12 times the number of cars I wash. And that's going to equal my earnings. So you may see it like this. You may also see it like this. Both of those are the same thing. They're just in different orders. The data in this table illustrates a linear function. What is the slope? So you could do graphing and say negative 2, 6, 0, 4, 2, 2, and 4, 0, and graph your line and find the slope. Okay, you could do that. You could also use y2 minus y1 over x2 minus x1 and choose any 2 points. I like the first one just because it comes first. So I can do y2, which would be this 4, minus y1 over x2 minus x1. So 4 minus 6 gives me negative 2. 0 minus a negative, which is plus a positive, is 2. And I could simplify this to negative 1. I could look on my graph. And I do see that for every spot I go down, I go over 1. So negative 1 over 1. That is negative 1 slope. So you can do it either way. Which hill described in the table is the steepest and why? Remember that steepness is the same as slope, and it is always described as rise over run. So it's vertical over horizontal. Vertical over horizontal. Vertical over horizontal. So which one of these is the greatest number? Remember, positive and negative don't matter for the steepness, but we do want to know which one of these is the greatest. The greatest one is Liberty Hill because it has the greatest slope because that fraction is the greatest. Graph the linear function. So on this one, we're looking first at our y-intercept. It's -1. So I'm going to put a dot at -1. And then my slope is 1 over 5. That means you're going to rise 1. So rise 1 and run 1, 2, 3, 4, 5. And we're going to put a dot. You could also go backwards, go down 1 and run 1, 2, 3, 4, 5. And then hopefully your drawing skills are a little bit better than mine here. But you get the idea of what that will look like. So you do get that straight line with a y-intercept of -1 and a slope of 1/5. Graph the linear function. Y equals -2x plus 5. So I've got a y-intercept of 5. And I've got a slope of -2. That means I'm going to go down 2 and to the right 1. Down 2 to the right 1. And I could keep going and connect my dots. If you're doing this on paper and pencil, hopefully you've got a ruler or a straight edge there that you can make that a little bit straighter. But you do see that it does go through 5 and it does have a slope of -2. What is the rule for the function shown in the table? So I'm going to look and I'm going to say, okay, this goes down 1, down 1, down 1. And my y's, that goes down 3, down 3, down 3. So it looks like this function has a slope, remember, it's always y over x, or rise over run, of -3 over -1, which is the same as 3. But it has a y-intercept of -6. So it'll have 3x minus 6. Mia charges $3.25 per hour when she babysits, plus $4 for the transportation expenses. Which function rule represents the amount y that Maya charges to babysit for X hours? So the total is going to be y. We know that's going to be right before the equal sign. Let's pretend Maya shows up and she babysits for 1 hour. You're going to have the $3.25 for the 1 hour plus the $4. If she shows up and babysits for 2 hours, she's got to get there, but you've got 2 times the $3.25. If she stays for 10 hours, she still just got to get there, but you're going to have to pay for 10 hours. So what's happening here? You're always going to add the 4. It's your y-intercept. And your $3.25 is going to multiply by the number of hours that she is working. Okay, if it says function rule, yeah, y equals 325x plus 4. The sale price of ground beef at a local grocery store is $1.29 for the first pound and $1.19 for each additional pound. Which function rule shows that the cost of ground beef y depends on the number of pounds? So, for 1 pound, it's $1.29. For 2 pounds, it's $1.29, and then $1.19. For 3 pounds, it's going to be $1.29 plus 2 additional pounds. For 4 pounds, it's $1.29 plus 3 additional pounds, and so on. So how do we make sure? Because if we wrote it like this, where it would multiply by x, to where it would add $1.29, if we look for 1 pound, that would tell us we would be adding $1.19 plus $1.29. We need that for 2 pounds. So we need to make sure this is x minus 1. So y equals $1.19 times x minus 1 plus $1.29. Now you may have it where it wants you to go ahead and distribute and simplify this out, where $1.19 is multiplied by both of these. So if we do that, you can combine like terms here. And get $1.19x plus 10 cents. Okay, you could write it like that as well. Now, what I want you to notice is you're taking the additional pound price times the x plus the difference in the two is what essentially happened there. The difference in the two prices is what you're adding as your y-intercept. Which function rule represents the data in the table? So we're going to find out what's going on here. So the x's, we go down by 3, down by 3, down by 3. And the y's, we're going down by 1, down by 1, down by 1. So we know that our slope is always y over x. It's always rise over run. So this one is -1 over -3, which is the same as 1/3, because a positive divided by a positive is a negative. And that's our slope times x. Now we have to find our y-intercept. So our y-intercept is a number for when x is 0. X is 0 right here, and y is 1. So you can either have y equals 1/3 x plus 1. You could also see f of x equals 1/3 x plus 1. You could see both of those different ways. Which quadratic rule represents the data in the table? So quadratic rules are a little different. Quadratic means x squared. So you know you're going to have a y equals x squared plus or minus the y-intercept. So always look up here and see where my y-intercept is. So I look for x is 0. My y-intercept is -3. So I have written my quadratic rule, x squared minus 3. And I could test a number in it if I wanted to. I'll test this one right here. Y equals x squared, so that would be 3 squared minus 3. Oh, sorry, 6. 3 squared is 9 minus 3. That is 6. 6 does equal 6. So my quadratic rule here is true. A 154-pound person burns 420 calories per hour riding an exercise bicycle at a rate of 15 miles per hour. Write a function rule to represent the total calories burned over time by that person. Explain how the information in the problem relates to the function. So we're looking for the total calories burned. So I'm going to call calories C. And the number of hours is H. So we know that they burn 420 calories per hour. So we need 420 times the number of hours they rode gives us the total number of calories. So 420 times the number of hours gives us the calories. Because they are riding at a constant speed and it's going to be the same person every time because it says by that person, we don't need the initial information. Okay, we don't need this. We just need the calories they burn per hour. Explain how to write a function rule from the table below. So we're going to find out the difference between our x's. We add 3. Then we add 3 again. We subtract 1. And we subtract 1 again. So our slope is y over x, the change in y, over the change in x. So it would be negative 1 over 3. So now we need y equals negative 1/3 x plus, we don't have a b up here. We don't have our y-intercept because x is not shown as being 0 anywhere on our table. So we're going to have to plug in a value to find b. So I like this 0 because I like nice round numbers. So I'm going to plug in 0 here for y and 4 for x. Now you could have picked any of those points. I just chose this one. So I'm going to say, okay, 0 equals negative 1/3 times 4 is negative 4/3 plus b. Now I need to get the negative 4/3 to the other side by adding 4/3. So b does equal 4/3. So now I can rewrite my equation to negative 1/3 x plus 4/3. So all I did was choose a point and plug it in for x and for y to solve for that y-intercept. The graph below shows the average daily temperature over a period of a year. Explain how each labeled section of the graph relates to the 4 seasons. So the temperature is kind of low in A, and then it slowly warms up, gets pretty hot up here in C, and then cools back down in D. So I would say C is the summer. I would say D is the fall. Winter, it's still pretty cold over here in A. And so that makes B spring when it's warming up.